Number 34. Number 34 is basically the pH of a solution obtained by adding 50 ml of 0.1 molar of hydrobromic acid, HBr. Okay? Look at the given, you will find that there is no pKa given for HBr, and anyway, هني قايلين إنه it's a strong acid. So, you have to add HBr to each of the following parts. Let's start with part A, which is 20 milliliters of sodium bicarbonate solution, 0.2 molar. Yeah. Number 34. Part A, which is basically HBr. Remember, HBr active is H3O plus with sodium bicarbonate. The effective species is, why did I do that? HCO3 minus. So you have HCO3 minus plus H3O plus, which is a strong. Let's say it's complete. لأنه أي شيء weak plus strong is complete. Remember, there is always a small percentage backward, even if it's quantitative or complete. تذكروا إن إحنا قلنا إن quantitative and complete are basically 99.9%. Okay, which is why you always have this small epsilon value to give me H2CO3 plus H2O. Okay, let's get started. It was, I think, around, خليني افتح document somewhere else, 20 milliliters of 0.2, so that's basically 4 millimole, and 50, 0.1, 5 millimole. So that's 4 millimole initially, and 5 millimole. When the reaction proceeds, limiting will be approximately 0 or epsilon. The H3O plus will be 5 minus 4, which is 1 millimole. And the H2CO3 will be 4 millimole, equal to the limiting value. So in your solution, you have a strong acid H3O plus, and you have the weak acid H2CO3. When you have strong plus weak, if the concentration of the strong is enough, and it's in most cases it is enough, neglect the weak. So basically, H3O plus is the number of moles, 1 millimole, divided by the total volume. It's always the total volume. It's 50 ml from HBr and 20 ml, I think, from the bicarbonate. So that's 70 ml. Millimole will cancel milliliter. بيبقى عندكم mole per liter, and 1 divided by 70, which is 0.0142 mole per liter. The pH is negative log 0.0142 mole per liter, which is basically, أكيد ما بحط المول per liter هون, 1.825 or 845. So that's 1.8, okay? Good. This is part A. Part B. Part B. هفتح لي questions أنا هون. So you're adding, again, you're adding 50 ml of 0.1 mole per liter HBr, which is basically H3O plus, to 200 ml of pure water, to 200 ml of H2O, and this is basically dilution. Just find the new concentration of HBr, and it's equal to 50 times 0.1 divided by the total volume, which is 250. Remember, milliliter for milliliter next to 250. And this is basically 0.02, okay? Which is greater than 3.2 times 10 to the power negative 7 validity. Then the pH هي negative log 0.02 okay, which is around 1.7. Find the actual value, which I think it has to be 1.68 something. Good. Part C. Again, 50 ml of 0.1 molar HBr is now added to third part 100 ml of 0.05 molar perchloric acid, HClO4, and this is a strong acid. Strong acid plus strong acid. I have two sources of strong acids. When you have two sources of strong acid, just find the total concentration. بس انتبهوا شوي. 50 plus 100. Both acids now exist in 150, not in 50, not in 100. They exist in 150. So you find the total concentration of H3O plus coming from HBr. HBr is basically 50 times 0.1 divided by 150 plus the acid coming from HClO4, which is basically 100 times 0.05 again divided by 150. And this is equal to 0.0667 mole per liter. The pH, أكيد is 0.0667 is greater than 3.2 times 10 to the power negative 7. pH is negative log 0.0667, which is around 1.176. Part D. Okay, part D, again, same question, 50 ml of 0.1 HBr added to 130 ml of what? 0.5 potassium nitrate, NO3 minus. Okay, now what is NO3 minus? Sorry, it's NO3, KNO3. It's KNO3. يعني it's basically NO3 minus and K plus. What is NO3 minus and what is K plus? Both of them are spectators. Both of them are spectators. It means that they do not affect the acidity or the basicity of the solution. So what you're doing is simple dilution. You're adding HBr to a solution containing spectators. This is simple dilution. The new concentration of HBr is 0.1 times 50 divided now by the total volume, 130 plus 50, 180. That's it. Okay, so it's 0.0278. That is greater than 3.2 times 10 to the power negative 7. So the pH is negative log 0.0278, and this is equal to 1.556. Part E. So again, HBr added to 1 gram of solid potassium hydroxide plus 1 gram of solid KOH. Now, when they tell me it's added to 1 gram of sodium potassium hydroxide or 1 gram of anything, you have to assume no changes in volume. Unless they say that the volume changes, but then you have to assume no changes in V. If no changes in V, it basically means that you have H3O plus coming from HBr and HO minus coming from KOH. And this is a complete reaction that yields 2H2O. What you have to find is the concentration of KOH. Very simple. The concentration of HO minus is the same as KOH. And the concentration of anything in terms of mass, it's what? Like I said, it's basically mass divided by molar mass. Why did it stop? Times the volume. Okay, so it is 1 grams divided by molar mass of KOH is 56.1 times the volume, which is basically the volume of HBr. What was it? It's 50 ml. Hon, you have to change into liters because there is nothing to cancel the milliliters. Okay, so, and this is approximately equal to 1.78 times 10 to the negative 2 mole per liter. Go back. Initially, this was 50 times 0.1. خلينا نحول للليتر this time. للمولز. Okay. And it is للليتر, sorry. 1.78 times 10 to the power negative 2. Obviously, hon, this is the limiting. So at the end, this will be a value of epsilon. And the remaining will be 1.28 times 10 to the negative 2. So now you only have a base. What is the pH? Same. Just greater than 3 times 10 to the power negative. Okay, find the pH اللي هي 14 plus log HO minus. Don't forget to calculate the concentration of HO minus. I don't think this is correct, by the way. Repeat this calculation, okay? Simply repeat this calculation because I think 1.78 is not accurate. And you can find the pH. And that's it. Part E, I don't think there's another part. Good. That was number 34. Let's start with number 35. In number 35, consider 1 liter of sodium sulfate solution, okay, which is basically HSO3. This is separated in Na plus, which is the spectator, and HSO3 minus. Calculate the pH of the solution, and we add, without any variation of volume, 0.05 of NaOH to S. Calculate the pH of S. So you have to calculate the pH before and after the addition of NaOH. Good. And we need the pKa for this. We don't have the pKa given. Oh, Bella, okay. pKa of H2SO3 HSO3 minus is 2.0. pKa of HSO3 minus SO32 minus is 7.2. Remember that HSO3 minus is basically the ampholyte. So, number 35, part A. What you have in part A is basically HSO3 minus with a concentration, I think, of 0.1 molar. This is an ampholyte. No reaction will take place. To find the pH of an ampholyte, it's basically pH equals to half pKa1 plus pKa2, which is half pKa1. It was around 2. pKa2 is 7.2. So that's 2 plus 7.2 divided by 2, 4.6. Very simple. Part B. To the same question, we add HO minus without any changes in volume. So HSO3 minus, and you add to it HO minus. What will happen? HO minus will take the proton to give you H2O. and SO3 2 minus. By the way, this is the second couple. Okay, pay attention. إنه ال SO3 2 minus HSO3, this is the second couple. You have 0.05 mole, 1 liter, so that's 0.05 mole per liter, 0.1. So initially, this was 0.1. خلينا على المول per liter, it's okay لأنه we're working in 1 liters. 0.05 mole per liter, nothing. Limiting, it's very obvious what the limiting is. At the end, this will be 0.1 minus 0.05 اللي هي 0.05, and this will be a value of epsilon. This will be 0.05. Pay attention, without any calculations, the conjugate is equal to the conjugate. pH is equal to pKa. The question, which pKa? طلعوا على couples. This is couple 2, so it's equal to pKa2. Couple 1 هي H2SO3. And if you get confused, هيهن الcouples. You should not be confused by the couples anymore. Okay? So pH equals pKa2, which is around 7.2. Part C. In part C, add to S the initial solution, I think S, which is HSO3 minus 0.1 molar. مش the solution that you get in B to the first one in A, without any variation on volume, 0.05 mole per liter of HCl. It's the same as B as A is as B, but instead of HO minus, they added HCl. Okay, so I have HSO3 minus. This time, you add HCl, which is H3O plus. Weak plus strong, you have to assume complete. H3O plus will lose a proton to HSO3 minus to get H2SO3 plus H2O. Start with the values, same volume. Initially, this is 0.1, this is 0.05, nothing. At the end, the limiting will disappear. بيبقى في 0.05, epsilon 0.05. Look at the conjugates, they're equal, so the pH equals pKa. Which pKa? Again, look at the couples. This is couple 1, so it's equal to pKa 1, which is equal to 2. And basically, that's number 35, okay? Now, try to do your own by adding the same value of HCl to, let's say, HSO3 minus or SO3 2 minus, or it doesn't matter, but in similar number of moles. So what happens if you add 0.1, 0.1? You will get SO3, you will get H2SO3 as 0.1. Find the pH then. Number 36. In number 36, you have 0.1 mole it's 94%. Okay. You have 0.1 mole of formic acid, HCOH, and X mole of sodium formate, the conjugate HCOO minus. This is HCOOH. Okay? Are introduced into 1 liter of H2O. Good, يعني 0.1 صارت 0.1 molar instead of mole. The pH of the solution is 3.75. Find X. Very easy. Henderson-Hasselbalch. It's very easily. Henderson-Hasselbalch. We go back. pH is equal to pKa plus log concentration of HCOO minus divided by the concentration of HCOOH, formic acid. Okay, so pH equals pKa, adel pKa around 3.75 plus log X, HCO minus is basically X, divided by HCOH, they said 0.1 mole per 1 liter, so that's 0.1 mole per liter. But some pay attention that the pKa and the pH values are exactly the same. So we didn't actually have to calculate, okay? We didn't actually have to calculate. دغري فينا نقول إنه X is equal to HCOOH equals to 0.1 molar. It's very easy. This is a buffer where the conjugate base is equal to the acid. Part B. $500 milliliters of water is added to the previous solution. What is the pH of the new solution? What do you think? You have a buffer. You add 500 ml. The idea is both the acid and the conjugate base will be diluted to the same extent. نفس dilution factor. The dilution factor هون, it's basically volume. The new volume is 500, so I think the new dilution factor will be around 0.0667. What happens? The concentrations will change in the same way, and the pH will remain the same. Remember, dilution does not change the pH of a buffer except if it's done excessively. Too excessively. I mean excessively up to the point when the autoionization can no longer be neglected. And this is number 36. Good. Number 37. No, let's start a new one.